as you compare Bank B and Bank C, what is the difference? And the difference is Bank C is going to look at the equal principal payments instead of fully amortized payments. And that doesn't mean much to you right now, but we're going to go through the example so that comes to light. And this is used by some lenders. In this case, if it's an equal principal payment and you're going to borrow $100 and you're making 2 annual payments and you want to know how much the principal payment is going to be, obviously you divide the principal amount by 2. In other words, you're going to make 2 $50 principal payments to pay off that amount of money that you borrowed. Now, to actually calculate the total payments, you can see that at time 0, okay, our loan balance is the $100 because that's what we're borrowing. If we look at time period 1, our beginning principal amount starts at 100. The interest that we pay is simply multiplying the interest rate times the beginning principal amount. So 100 times 12.5% is $12.50. Notice that the principal payment was already determined to be constant at $50. So the total payment, we just have to add the interest plus the principal is going to give us the total payment, which is 62.5. And then to find out the loan balance, that's easy. We take the beginning principal amount, we subtract out the $50 principal payment, and 100 minus 50 is 50. So the loan balance at the end of the period is 50, which becomes the beginning principal amount that we start with at the beginning of period 2. Notice that the interest is cut in half because it's 12.5 of the remaining balance of $50. So the interest is 6.25. We add that to the principal amount, and that gives us a total payment of 56.25. And then 50 minus 50 is going to give us 0. So it's just like the amortization schedule. We just changed it a little bit because where in the fully amortized amortization schedule, the payment was uniform across the life of the loan. In this case, we have a uniform principal payment, and the payment is adjusted. Okay, if we look at the comparisons now between the fully amortized loan and the equal principal loans. The fully amortized loans is what we've been doing up till today. The bottom half of this screen is for the equal principal loan. And looking at the comparisons, the total payment for the fully amortized loan, if you recall, is uniform. It's just flat across time, where the horizontal axis represents time and the vertical axis represents the dollar amount. But if you look at the principal payment for the equal principal loans, it's uniform. For the fully amortized loan, the total payment's uniform and constant. For the equal principal loan, it's the principal payment that's uniform and constant. Whereas if the fully amortized loan, if you look at the principal payment, it's not constant. Actually, it's going up over time because you're paying less interest. If you look at the total payment for the second type of loan, notice its total payments are going down. Hopefully you can see that there's some liquidity implications to that. If you look at the interest payment for both of them, in both cases, they are declining over time as the principal declines. Now, if you look at the total payment, where both are on the same chart, as we said for the fully amortized loan, it's uniform. If you look at the green line, which represents the equal principal payment, notice that you start paying more money at the beginning, but you pay less at the end. So if you're strapped for cash on the beginning part, like on a land loan, where you're going to have some cash deficits, which one are you going to go with, the fully amortized or the equal principal? The fully amortized, because you see it has a lower payments at the beginning. Later on, it changes. If you look at the principal payment, you can see that for the fully amortized loan, the reason that you're paying the total payment is less is because you're paying less principal at the beginning. But over time, you're able to pay it off faster. Now, this is the next kicker in this. If you look at the interest payments, notice that you pay less interest overall with the equal principal payment. So from a liquidity standpoint, you like the fully amortized loan. If you don't like paying interest, which one do you go with? You're going to go with the equal principal. Now I'm going to come back to this when we actually see the results, and I'm going to remind you of this chart, then question your judgment. So keep this chart in mind here as we go through this. Okay, for Bank C, you can see that the principal is 100. The payment of 62.5 and 56.25, if you go back to that amortized chart several slides back, you'll see where those numbers are coming from. You might want to identify that. They come right out of that column where it says total payments. And then we have no fee and no stock, so you can see the net cash flow at the bottom again, where you pay $100, and then you have a total payment of 62.5 the first year and 56.25 the second year. So you see, just as we said, the total payment is going down. Now to calculate the yield, our life is a little harder here, because now we don't have a uniform payment. We have two single sum payments. And so we have to find the present value, of course, bringing the first payment back 1 year, and the second payment back 2 years. And we're trying to find this rate that's going to make the left-hand side equal to the right-hand side. Now in this particular case, we don't have a way to plug that into your calculator, at least with the 5 standard functions, so we're going to search for it. And we're going to basically choose a rate, and then we're going to look at what that means to the left-hand side and the right-hand side. The present value of cash inflows is $100. It doesn't change. Let's just pull a number out of the hat. Let's try 10%. We plug 10% into this equation, and both those numbers do the arithmetic, and the present value of the outflows comes out to be $103.03. Since that's greater than the inflows, okay, let's try a higher rate. Let's try 14%. We plug 14% into that equation, and we see that the inflows are greater than the outflows. So we know it's somewhere in between 10% and 14%. So let's try something between it. Let's try 12%, and we plate 12% into the R. 12% is still a little bit too low. Let's try 13%. 13%, well, it's a little bit too high. So let's try precisely 12.5%. And they are equal. So the yield is what? 12.5%. Is that the same as the contractual rate or the APR? And the answer is yes. Just a heads up, that's always going to be the case. Just like it was for the fully amortized loan, that's also true of the equal principal payment when we don't have any non-interest cost associated with it. Okay, so to calculate the APR, since this is annual, we just multiply it by 1, so the APR is the same as the actuarial rate. Calculate the effective rate, because it's also annual, the effective rate is also 12.5%. So for Bank C, in comparing Bank B and Bank C, notice that the effective rate is 12.5% for both of them. Now, this is your question. I said I was going to refer back to that graph that I showed you, that you clearly paid less interest with the equal principal payment. Then how is it that, and I can stand here and tell you that the effective rate is the same for both of them. Even if this had been a 15-year loan, we did everything the same, the effective rate still would have been the same in both those banks. It's because with the equal principal payment, you paid the principal off faster, so you didn't have the use of that capital as long, so you pay less interest in total. But on the outstanding balance at any particular time, you're paying the same interest rate. That's why the effective rate is the same. You pay less interest because you don't have the money as long.